Welcome to this explainer. You know, if you've been tuning into the tech world lately, you've probably heard this massive, super tempting myth. The word on the street is that AI is such a huge paradigm shift, we can just toss all our old software rules right out the window. It spawned this whole specs to code movement. The pitch? You just scribble down a plain English spec, toss it to an AI, and bam, perfect software. But as we're going to see today, diving into some awesome insights from Matt Pocock, the reality is, well, it's totally different. Software fundamentals actually matter now way more than they ever have.
So, let me ask you, and be totally honest here, have you ever let an AI write code for you only to end up with absolute garbage? Like, you write the spec, the AI spits something out, it bombs, so you tweak the spec and run it again. You're trying so hard not to actually look at the code it's writing, but when you finally peek under the hood, you realize it's getting progressively worse with every single iteration. It's a super common trap, especially when you're leaning heavily on these AI coding agents. Trust me, if you've been there, you are definitely not alone.
All right, let's figure out why this actually happens. If you've read the classic book, The Pragmatic Programmer, you might remember this brilliant concept called software entropy. In plain English, it's the natural tendency of a system to drift toward a complete, tangled disaster if you're only ever thinking about isolated, one-off changes. When you use AI just to blindly patch a bug here or tack on a feature there, without looking at the big picture system design, you aren't just creating tech debt, you are hitting the gas pedal on entropy. The codebase literally collapses under its own weight. And that brings us to a massive misconception. The whole specs to code movement runs on this idea that code is cheap. But guys, that is fundamentally flawed. Code is not cheap. In fact, bad code is literally the most expensive it has ever been. Why? Because a messy code base makes it completely impossible to change things without causing a massive cascade of bugs. And the kicker? If your code is hard to change, you completely break the AI's ability to actually help you. A clean, fundamentals-first code base is your absolute ticket to unlocking the true power of AI.
So here is our step-by-step masterclass tutorial to dodge these major AI failure modes. First, we'll look at the problem-solution matrix. Then, Skill 1, the Grill Me process. Skill 2, Ubiquitous Language. Skill 3, Test-Driven Development. And finally, the Architecture Checklist.
All right, Part 1, the problem-solution matrix. When you map out exactly where AI goes off the rails, it turns out classic software books already hold the answers. If the AI builds the wrong thing, you need a shared design concept. If it's talking in circles and being way too verbose, you need a ubiquitous language. And if it builds something that just flat out doesn't work, you need test-driven development. So let's break down exactly how to put each of these three solutions into practice.
Moving on to skill number 1, the Grill Me process. In his book, The Design of Design, Frederick P. Brooks talks about something called the design concept. Now, this isn't a markdown file or a specific asset. It's that invisible, shared, kind of ephemeral theory of what you are actually building together. And here's the thing. When you and the AI don't share that same design concept, the AI is basically just guessing. AI tools are super eager. They just want to generate a plan and start typing. You have to put the brakes on and force a shared understanding first.
Here's the exact playbook to make that happen, using what we call the Grill Me process. Step 1, you give the AI a prompt that turns it into an adversary. Tell it to relentlessly interview you about every single detail of your plan. Step 2, have it walk down the design tree to resolve dependencies one by one. The AI might ask you 40, 60, maybe even 100 questions, and you just keep answering them until you both hit total alignment. Only then, at step 3, do you let the AI generate your product requirements document, or PRD. You are literally forcing clarity before execution.
Next up, skill number 2, ubiquitous language.
To tackle an AI that's way too wordy or getting confused, we can steal a trick from the classic practice of domain-driven design. It relies on this concept called ubiquitous language. Think of it as a shared, agreed-upon dictionary. Veteran developers have been using this exact technique for years to get on the same page with non-technical domain experts, just so nothing gets lost in translation. Well, we need to do the exact same thing with our AI.
And implementing this is actually incredibly straightforward. First, you can literally just use the AI to scan your current codebase for recurring terminology. Then, step 2, compile all of that into a simple markdown file with tables of these key terms and their strict definitions. Step 3 is where the magic happens. Keep this file open and explicitly feed it to the AI during your planning and Grill Me sessions. You will instantly see the AI's reasoning become way less verbose, highly focused, and perfectly locked in on your actual domain.
All right, on to skill number 3, test-driven development.
I absolutely love this quote from the pragmatic programmer: "The rate of feedback is your speed limit." You see, AI naturally wants to outrun its headlights. Left to its own devices, it's going to generate these massive, unchecked blobs of code without ever pausing to check a static type, run a test, or see if the thing actually compiles. It's basically driving way too fast in the dark.
The ultimate fix here is test-driven development, or TDD. By forcing your AI into this classic three-step loop, you establish a hard speed limit. Step 1, force the AI to write a failing test first. Step 2, generate just enough code specifically to make that one test pass. And Step 3, refactor the code to improve the design. TDD acts like a leash. It forces the AI to take small, deliberate, highly verified steps, rather than just hallucinating 500 lines of completely broken code. And that brings us to our final section, the architecture checklist.
John Osterhout's book, A Philosophy of Software Design, gives us a totally perfect lens for this: deep versus shallow modules. AI gets completely, hopelessly lost when exploring shallow modules. We're talking about those scattered files with highly complex interfaces and tons of tiny, exposed moving parts. The AI has to jump between dozens of files just to get the context. But what AI actually thrives on? Deep modules. These are modules that have beautifully simple interfaces on the outside but hide a massive amount of complex, heavy-lifting functionality on the inside.
To picture this, think of a deep module using the gray box analogy. You, the human developer, your job is to design the simple buttons on the outside, the clean interface. Then you explicitly delegate the internal implementation to the AI, letting it wire up all the complex electronics on the inside. Doing it this way completely saves your brain from utter exhaustion. Why? Because you only have to understand and control that testing boundary instead of trying to keep every single line of AI-generated code crammed in your head.
So, to make this really actionable, here's a structured checklist you can use to evaluate your AI-generated architecture. Ask yourself, are the boundaries around my related code clear and simple? Am I testing functionality solely at the interface layer? Are my modules deep enough, effectively hiding the inner complexity from the rest of the app? And finally, when I write my PRD, am I explicitly defining exactly how the interfaces will be modified? If you can answer yes to these questions, you've got an architecture that is going to rapidly reward AI assistance.
There's an insight from software pioneer Kent Beck that I find super interesting, especially because it totally rejects that modern specs-to-code mindset. He says, invest in the design of the system every day. The specs-to-code movement basically tells us to divest from system design, just ignore the code entirely. But true professionals know that to succeed, especially when you have an AI coding at light speed, you have to invest in the design of your system every single day.
Ultimately, it all comes down to shifting your identity. You've got to stop viewing yourself as just a prop writer and start acting like the high-level design strategist. The AI, that's your highly capable, tactical sergeant on the ground writing the actual code. But a sergeant needs orders, they need structure, and they need a clear battle plan. You need those 20-year-old software fundamental skills now more than ever to direct that AI effectively.
We absolutely have to dismantle this myth that code is cheap. It's just not true. Bad code will cost you your entire project's velocity. Maintaining a highly readable, deeply modular, test-driven codebase is literally the only way to reap the massive productivity bounty that AI tools offer.
So, I'm going to leave you with this final thought. Are you ready to stop fighting your AI and instead step up as the ultimate design strategist for your tactical AI sergeant? Start implementing the Grill Me process, define that ubiquitous language, enforce TDD, and architect those deep modules. If you found this explainer helpful, I highly encourage you to go check out Matt Pocock's skills repository and try putting these fundamentals into practice yourself. Thanks for learning with me today.